I think I can give you maybe 2 minutes to construct a tree by using these two sequences. And remember, the idea of doing it is that we recursively trying to find the root node of a tree or of a subtree. Then we find out which nodes are in the left subtree, which nodes are in the right subtree. Then we repeat this process, find the root node of the left subtree, find the root node of the right subtree, and so on. So let's spend about 2 minutes, try to reconstruct the original tree, and then we try to do it together and find out the post-order traversal sequence. Right, let's try to work out this together. As we just mentioned that if we look at the pre-order traversal sequence, we can immediately tell which is the root node. I think this case is very clear that 14 has to be the root node of the entire tree. So I have 14 written here as the root node. And now the second step would be, let's try to find out which nodes are in the left subtree and which nodes are in the right subtree. And in order to do so, I think we need to rely on the in-order traversal sequence, because remember that when we apply in-order traversal, we will have all the nodes in the left subtree visited before we visit the root node. Then after visiting the root node, we will jump into the right subtree and then visit all the nodes in the right subtree. So I think in this case, we can first try to locate the root node 14 in the in-order traversal sequence, which is here. Then we know the first 4 nodes, 63, 83, 19, and 42, these 4 nodes must be from the left subtree. And the last 5 nodes, 27, 99, 51, 74, and 37, must be from the right subtree. So I'll have the first 4 nodes marked in red color, indicating that these nodes are in the left subtree. And these 5 nodes marked in blue color, indicating that they are from the right subtree. Also, I think we can mark these nodes in the pre-order traversal sequence. So 4 nodes in red and then 5 nodes in blue. Now we've done the first iteration, and next step what we want to do is maybe let's try to construct the tree or the subtree, which is the left subtree. So again, we want to identify the root node of this subtree, then find out which nodes are in the left subtree of it, which nodes are in the right subtree of it. So I think what we're going to do is, let's look at the pre-ordered traversal sequence again. Since we know these 4 nodes marked in red square, they are from the left subtree. And when we traverse this subtree using pre-ordered traversal, we're going to first visit the root node, then followed by all the nodes in the left subtree, then all the nodes in the right subtree. So the first node here must be the root node. So 83 is the root node of this left subtree. And following the same idea, we locate this 83 in the in-order traversal sequence, which tells us which nodes are in the left subtree and which nodes are in the right subtree. Clearly, in this case, there's only one node in the left subtree, which is 63. So I think we can directly draw it here. And there are 2 nodes in the right subtree, which are 42, 19, or 19, 42. Well, in pre-ordered traversal sequence, visiting these 2 nodes give us 42, 19. In order traversal sequence, visiting these 2 nodes give us 19 and 42. Maybe I'll just use a different color to just indicate these 2 nodes. And we know both of them are in the right subtree. Now, in order to find which is the root node of this subtree, I think, again, we look at the pre-ordered traversal sequence, giving us 42. So 42 must be the root node of this right subtree. And since 19 appears before 42 in order traversal sequence, we know that 19 must be from the left subtree. All right, I think that's it. We've already recovered the root node and all the nodes in the left subtree. Then let's move on to the right subtree, which is indicated in blue color. So the root node first, which is 27, that's quite obvious. 27 is the root node here. And since 27 is the first node being visited in this subtree, when we use in-order traversal, it tells us that we cannot have a left subtree of 27. So all the other 4 nodes are in the right subtree. And for this right subtree, the root node must be 74. And since 74 is here in our in-order traversal sequence, then we know we have 2 nodes in its left subtree, which are 99 and 51. They are in the left subtree. And within this left subtree, the root node must be 99, as we can get from the pre-ordered traversal sequence. 99 is visited before 51, so 99 is the root node. And for the node 51, since 51 is being visited after visiting 99 in order traversal sequence, so 51 must be the right child of 99. And remember, we have the last node 37, which is the right child of 74. So we're just going to place it here. So I think that's it. We've just reconstructed the entire tree. And quickly go through the idea. Each step when we want to recover a tree or a subtree, we first need to find the root node of that tree or subtree. After finding the root node, which is the first node in the pre-ordered traversal sequence, we locate that root node in the in-order traversal sequence as well. Then all the nodes to its left are from its left subtree, and all the nodes to its right are from its right subtree. And we repeat this process until we have the entire tree. Now that we have the tree here, the question asks about the post-order traversal sequence. I will just give you maybe 30 seconds for you to quickly find out the post-order traversal sequence. And then, well, at the same time, I will also work it out on my screen, and you can have a check if you want. So the post-order traversal sequence I get is 63, 19, 42, 83, 51, 99, 37, 74, 27, 14, as shown on my screen. I hope I didn't make any stupid mistake, but in case you get a different order, feel free to let us know. In past years, I think people may ask a question. Here, in this task, we had pre-order traversal sequence and in-order traversal sequence, and we reconstructed the tree, and of course, we can find the post-order traversal sequence. Is it always the case that given the 3 out of these 2 traversal orders, can we construct the tree? Because it looks like if we are given pre-order and in-order traversal sequence, we can always be able to construct the original tree. Because pre-order traversal always give us the root node, which also splits the in-order traversal sequence into 2 halves, and then we can recursively solve these 2 subtrees until we have the entire tree constructed. Now, what if we have pre-order and post-order, or we have in-order and post-order? Would it still be possible for us to construct the tree? I think if we have in-order and post-order, we can still do so because in the post-order traversal sequence, we know that the root node is the last node being visited. And again, this will split the in-order traversal sequence into 2 halves, telling us which nodes are in the left subtree and which nodes are in the right subtree. So the similar idea can be applied here. We find the root node, and then we know which nodes are in the left subtree, which nodes in the right subtree, and then we can recursively solve these 2 subtrees. Now the problem is, what if we have pre-order traversal sequence and post-order traversal sequence? Is it still possible for us to find the original tree? And I think the answer is no. I'll just use a quick example here. Suppose we have a tree. A is the root node, having a left child B. And I'll also give another tree. A is the root node, having a right child B. Now for the first tree, pre-order traversal sequence give us AB, post-order traversal sequence giving us BA. And for the second tree here, pre-order traversal sequence give us AB, and post-order traversal sequence give us BA. Clearly, these 2 trees are different, but they're giving the same pre-order and post-order traversal sequences. This means that if we only give pre-order and post-order traversal sequences of a tree, it may not be possible for us to reconstruct the original tree. But if you have in-order traversal sequence together with one of pre-order or post-order traversal sequence, then it must be possible for us to reconstruct the tree. All right, I think that's pretty much for question 53.